This episode of Serverless Chats is sponsored by New Relic. This week, I chat with Tyler McMullen about serverless compute at the edge. This is Serverless Chats, episode number 84. Hi, everyone. I'm Jeremy Daly, and this is Serverless Chats. Today, I'm chatting with Tyler McMullen. Hey, Tyler, thanks for joining me.
Hey, Jeremy. Nice to see you.
So you are the CTO at Fastly. So I'd love to know a little bit about your background and what Fastly does.
Well, I'll start with what Fastly does. Fastly is an edge cloud platform. So what that ends up meaning is that we help people to move their content as well as their logic, their actual programs, out to run on the edge of the network. The whole goal of that is to make things much faster for your users, better user experience, as well as much more resilient. And it's a really actually like a super exciting place to be, in my opinion. I got into, we founded Fastly, oh wow, 10 years ago now, maybe more. Can't remember off the top of my head now. But it's been a while. And I remember getting into it specifically because Artur, who was our CEO and our primary founder, came to me and he was like, "Hey, I have this idea. It's like a content delivery network, but it's more like an edge computing network." And I was working at a startup at the time, and I said, "That sounds extremely exciting." Like as like a distributed systems nerd, that was just, oh man, it's catnip to me.
Right.
And so for the last 10 years, it's continued to be exciting. That's how it got started there.
Awesome. And what about your background?
My background is, I was just a kid who taught myself to program, and got into got started working when I was about 16 years old, and had just kind of never stopped. I kind of skipped the whole college thing and just hopped from startup to tech company to startup.
Awesome. Well, so I'm a huge fan of serverless. As you know, again, I do a serverless podcast, so it's probably quite obvious to people. But one of the things that I am absolutely fascinated with is the idea of serverless computing at the edge, right? Which is one of these things that Fastly is doing. And I just think that there's a possibility that this could be sort of the future of serverless computing, right? Like no more, data centers or things like that or regions. It's just like right at the edge and as close as possible, that we could get to the user that is actually interacting with this stuff. So obviously a huge challenge, right? Lots of things that need to be done to make that happen. But I think what would be great for the listeners is if we just take a step back and kind of explain exactly what we mean by compute at the edge.
Sure, sure. So it's actually a great question because this is something that keeps coming up. Like for years, I have been like trying to explain exactly like what is edge computing, right? And the problem is that everybody has a different opinion as to what exactly it means, right?
Right.
And I think the ultimate problem is that depending on who you talk to, like that person is like familiar with or working on one particular line, like one particular edge effectively of that network, right? And so if
Mm-hmm.
you're talking to someone who works at a telecom, they're going to talk about 5G and about how it means servers inside of cell towers effectively, right? Meanwhile, you talk to like a traditional, say, like ops person, you talk to like an ops person from the 90s, right? The way that they think about the edge is actually the edge of their own network, right? It's kind of the border between their autonomous system and like the rest of the network, the rest of the internet, right? You talk to me, you're going to talk we're going to talk about uh, metro area data centers as well as like even more narrow ones. You talk to, anyway, the list goes on and on, right?
Right.
And so to me, I think it's actually kind of the problem is actually, in my opinion, in the word. It's the problem is the word edge, right? Because it implies a line. It implies like a specific point within the network, and I don't think that's actually true, right? Because if you think about like all of these different places that we're talking about, like having computation, they all have really important similarities in their models, right? And the point is that it's not the client, it's not like actually like the person that you're interacting with, and it's also not within your own like specific data center. It's not within your core computing, right? And everything in between there has a certain set of problems. It means that you don't necessarily have direct access to a database. It
Right.
means that you probably have to think about doing things in a little bit more of a stateless way. It means that you need to think about doing things at like high performance, right? And so I think that when we talk about edge computing, what we're really talking about is computing in the middle. It's between you and like your data center and your actual client.
Right. Yeah, and I think about it a lot. Like I try to look at it like a CDN, right? And I think of something like a Cloudflare or even CloudFront with AWS, right, where they have all these points of presence all over the world. And generally, I mean, even Akamai and some of these other ones that have been around for a really long time. Thinking about you store some sort of static asset somewhere at the edge, right? So it's a PDF that people can download, or it's an image that loads faster. Or what's been really cool happening now is a lot of the stuff with Jamstack, where they're putting HTML, pre-rendered HTML pages on the edge,
Yeah.
and so things are just loading insanely fast. But the idea of finding somewhere to do compute where actually you can run some sort of business logic, and that business logic might be as simple as saying, do I route them to the login page, or do I route them to, a sign in page, or whatever it is, right? Like I route them somewhere differently. But the logic could be much more complex as well. And that's kind of what's interesting to me is if you think about it as sort of a CDN, but with compute, then that unlocks a lot of really powerful use cases. So I'm just curious where you see edge computing, I guess maybe a mixture of what we just talked about, some sort of hybrid of the definition, where you see edge computing sort of integrating with what you think of as a traditional CDN.
Oh, that's not where I thought you were going with that question. That's
Oh,
really cool. Yeah, this is great. Yeah, I mean, I think it's like the mirror of it, right? Like you talk about a CDN, you're talking about moving the content, right? And now we're talking about moving the logic that generates the content,
right.
right? And so like the integration there, I think is actually going to end up being for a lot of folks super tight. Like it's actually, in my opinion, going to be pretty hard to have a like proper like widely used edge compute network without
Right.
actually having a CDN attached to it, right? And I think there's a bunch of different reasons for that. One of them is that like, almost by its own definition, you're going to end up running the same code repeatedly, right? If we're talking about like an HTTP, like a website of some kind or an API of some kind, you're going to be like loading the same things repeatedly. Just realistically, that's how the internet works. There tends to be like a tail for a spike in a tail for like how content is accessed on the
Right.
internet. Um, and so like when we're talking about putting servers out at like the edges of the network, we're almost certainly talking about a limited resource of some kind, right? Like if you're talking about, say, a big data like machine learning type of thing, like where you need a large amount of compute power to do it. You're not doing that at the edge of the network, right? You're not doing like training models at the edge of the
Right.
network. And the reason for that is because it's a lot more expensive to have servers in downtown Tokyo than it is to have them in like the middle of the desert in Utah, for
Right.
instance, right? And so coming back to it, like ultimately, like you're going to need to be doing quite a bit of caching. You're going to need to store data so you're not having to like repeat the same things over and over and over again. I think to me that's like one of the key reasons why the two are almost inseparable, in my opinion.
Right. Yeah. I mean, and I like the idea of, again, the caching aspect of it, of being able to cache those static assets, whether they're HTML or, I mean, with compute added to it, there's a lot that you could do to those static files that were cached, where you wouldn't need to make those home runs and you wouldn't need to do that. And you could use things that were local to that particular CDN or that particular POP. Anyways, I find that fascinating, but I think there are a lot of different use cases, and I'd be really interested sort of hear from you, like what are some of the use cases that you see people doing with compute at the edge, and maybe what are some of the ones that will eventually open up?
Yeah, yeah. So I think this is similar to like any other like new technology that comes out. You're going to have like the initial use cases, which we're going to think are really cool. And then eventually, in like a couple of years, you're going to get the ones that are actually the real killer use cases that we didn't
Right.
even think of yet. But like, so a lot of the initial ones are really simple. They're simple things that make a big difference in end user, perception of performance, right? So for instance, if instead of having to go all the way back to your centralized data center for every piece of data, well, what if, I actually have 90% of that data because it's static data that's already
Right.
sitting at the edge of the network. And now I just have to go grab that 10%. Or maybe I can feed you some of that while like gathering the remaining stuff. So a lot of people think about like think about how to put this. Better way to put this is like imagine like running a GraphQL server that runs at the edge. You get one request which actually fans out to multiple different requests. Most of them are already cached, and so you're dealing with a much smaller amount of latency, a much smaller amount of variability in latency. I think most
Mm-hmm.
particularly, you'll also see quite a bit of like page rendering at the edge, in my opinion. Right, a lot of that static data is already there, so why send down two different responses? Why send down multiple different responses? Let's just smash it together right there at the edge, and
Right.
it's down. Um, Longer term, I think we're going to see all sorts of wild stuff. Like, so one of the ones that we worked on internally, just as a prototype, as like a little idea, is actually games at the edge.
Mm-hmm.
So what if you could use an edge compute network to do not only like matchmaking of games, but to actually store the state of an ongoing game. And so
Right.
one of our like little hack day projects that we had was doing a multiplayer version of Doom that ran at the edge. And it's
Nice.
actually fast. It works. It's really cool to be able to like get a bunch of people together to play Doom and have all of the state actually just sitting there at the edge, ready to go. Right? You can get much closer to like a real time type of environment than you could typically with like a traditional game network.
Right. Yeah. No, and I love some of those ideas. I mean, one of the things you said about you maybe can request, 90% of the things you need are local or cache, and then you have to go out and get that other 10%. I think about asynchronous processes that you could kick off where you could say, a user goes to a particular page, and then you could say the likely place they're going to go next is going to be, X page or something like that. So now
Indeed.
you could preemptively fetch pages and make sure those are loaded into the cache for things like that. Now, of course, with the GraphQL example, that's an interesting use case because think about just the complexity of that request too, like knowing when to fetch it from local cache versus when to fetch it from a home run and things
Exactly.
like that. So that opens up a lot of, probably a lot of interesting challenges there.
Yeah, yeah, no, fully agree. The other one I wanted to bring up is actually like security, compliance, privacy related
Right.
things, right? So that's one of the hardest things for us to deal with, and we keep seeing the ramifications of this not being done particularly well in our industry. But like, imagine being able to have a single layer of your network to be able to do all of that, right? To be able to say, actually, that's a password. I've seen that it's a password. That
Hmm.
definitely can't be printed out in in plain text within this page, or being able to confirm that certain data just isn't leaving a particular layer of the network. It gives you a single
Right.
point at which is, I say single point, but it's actually spread across the world. But it gives you a single deployment point for you to be able to say, this is our last chance. This is the point, but before you actually get to the end user.
Right.
I think it's going to end up being a really powerful like security tool for people.
So, so speaking about all around the world, right? So this is one of the things that is sort of really interesting about edge computing or just even CDNs. The idea of replicating this to these points of presence, right? These POPs that are all around the world. And the question is, or the question I have for you, because I've read all of this stuff, and I am not an edge expert in any way, shape, or form, but I try to read up on this stuff because I find it fascinating. And one of the things I've seen is companies like Verizon and even AWS partnering with other people doing the 5G thing, like putting compute or pops on the cell phone towers. And I guess my question for you is, how close do we actually need to get to the customer? Because that's pretty insane if you can do, if you're, I mean, again, we'll get to the data piece in a minute, but if you're able to do compute and pull data from the cell phone tower that's a mile down the street versus having to route it to, somewhere on the west coast of the US or, North Virginia or something like that.
Sure. Yeah. I mean that is wild. I have actually heard even some even wilder ones where there was one person pitching me on the idea of putting servers inside of light poles inside in
Oh,
neighborhoods,
jeez.
where I'm like, why?
Right. Why?
So there are undoubtedly going to be use cases where that kind of thing like is actually useful, right? And the trouble with it though is that there's going to be such limited computing power in these
Hmm.
places, such limited storage in these places. And in order to make it worthwhile for you to use these, whatever you're doing has to be something that is not just for one particular users there. right? This has got to be
Right.
something where it is actually like so popular and so important that like it is worth it for you to spread this to say tens of thousands or hundreds of thousands of locations around the world. My argument is that metro area, city layer, like city area, um, basically being within, say, like 15 milliseconds, 10 to 15 milliseconds of users is plenty for the vast majority of use cases.
Hmm.
Now, I can be proven wrong about that, 10 years down the line, 15 years down the line, when we come up with like some wild new use cases that require you to be within like, 100 microseconds of where your end user is. But that's not what we're seeing right now.
Yeah.
We'll undoubtedly see some specific use cases where this is like very valuable, but that's to me not the most important form of edge computing, and that's why, right? Because like you can find use cases for something like what we're developing with computed edge for nearly any site. Like you can use this to make nearly any site faster.
Right.
It's going to be a lot harder, in my opinion, for these for like the cell tower layer ones. And there's actually a bunch of other reasons why it gets concerning as well. Like, one of the things that people trust Fastly quite a lot to be able to handle their private data. Like we own, or like we hold TLS keys for a lot of our customers, right? And so it's really important for us to have like incredibly strong security to be able to keep that sort of thing safe so that, your connections can't be snooped on. It's a lot harder to keep 100,000 locations safe than it is to keep
Right.
the number of locations that we have safe, right? You can't say as many, you can't make as many strong guarantees about like the security of a cell tower as you can about like heavily guarded data center that is like
Right.
nearby in your town.
Right. And I guess one of my questions is when I see people wanting to do those things, like putting them in the cell phone tower, like it sounds really cool, and there are probably use cases for that.
Oh yeah.
The idea of like self-driving cars, for example, that maybe need to ping a network or something like that. I mean, or the remote surgery, although I don't know how much that would use edge networks, but things where maybe 15 milliseconds isn't enough. I mean, do you see there being use cases where there's just some extremely low latency that's needed?
Sure. I mean, it's certainly possible. I mean, I do like. I have very mixed feelings about the whole self-driving car pinging the network thing. Like to
Yeah.
me, if your car requires the network to go like to move safely, oh man, we're gonna have some real troubles in the future. There again, I think there's definitely gonna be some use cases. I don't see them at the moment though. Maybe that's lack of imagination on my part, but we'll see what happens.
Right. Well, anyways, I mean, I do think that there are probably use cases, not necessarily to drive, but for like traffic updates, or if
No
there's
doubt.
accidents, things like, things that would potentially, although again, 15 milliseconds is pretty
Exactly.
fast.
And
So,
that's exactly where I go back to. As soon as people bring those things, I'm like, do you really need it in half a
right.
millisecond rather than 10?
Right. Probably
Yeah.
very true. All right. Awesome. So the other thing I think that happens with this, and again, you mentioned, sort of securing hundreds of data centers or hundreds of, cell phone towers, or these smaller pops or whatever. That gets really, sort of difficult from a security standpoint. Sure. But what about just from a, I guess, for building applications, like how does the idea of now moving compute to the edge, how does that affect sort of, I guess, the future of distributed applications?
Yeah. This is a great topic. And I think that no one really knows the answer to this yet. We're working on this. Um, so I think there's going to be a few stages to this. The first one is kind of where we're at now, where people think of the edge as like it's a proxy of some kind,
Right.
right? And like you think of it the same way as you might think about like, oh, well, I'm going to put some logic into my Nginx server that will run across all of my microservices that are behind it, or something like that, right? Or into my ELB or something. Um, I think that over time, what we are going to see, and we're already starting to see this actually with some of the ideas that are coming out now, uh, is people starting to think about the edge as just part of their application, right? In the same way, and like here's why I believe this. Like in the same way that people now think about like the client as part of their application. Like that's not how we thought about the client a long time ago. Like I was a developer back in the 90s. Like I remember how we thought about browsers, right? And like the browser was the dumb thing, right? Like it
Right.
was essentially a dumb terminal. And like, you would do all of the rendering, all of everything back at the server layer, and the browser was just there so that the user had something pretty to look at, right? And then over time, that's not how we think about the the client anymore, right? Like front end development is real development. It's like just as hard and just as serious as like back end development these days. Um, and so
Might
I
be
think,
harder.
yeah, no, you could definitely make that argument. You'd probably be right. Um, and so I think we're kind of in the early stage of that with edge computing at the moment, where people still kind of think about it as like, well, it's just this, I can run like little bits of code there, right? But at a
Right.
certain point, we're going to get to the where. Let me step back. Like what I really want people to think about with this is about like where is the most efficient, advantageous place for me to run this code. And for some things, that's on the client. And for some things, that's in a data center somewhere. Some places it's in a database somewhere, right? But there's going to be a large swath of things where the edge is actually the correct answer to that, right? Like where if you're not needing to do, like in some ways, I actually want to think about it as like being as close to the user as possible should be the default, right? If you can run something on the client and it's a powerful enough client, it makes a ton of sense to just run that code there because it's right
Right.
next to the user, right? Um, and so unless there's a strong reason not to, like moving things as close to them as we can, I think is actually going to be a pretty important development over the next few years.
Yeah, no, I totally agree. I just, my concern is, and it's less of a concern and more of a like a we don't know yet, is how does this affect how we've learned to build distributed applications over the course of the last, sort of 5 to 10 years, right? Like it was always like, you start off building monoliths and then we get into the cloud and then we start building distributed systems and we're getting better and better at that. And then all of a sudden we're like hyper distributed systems now because we want to put them, we want to replicate our applications, closer to the client. So I mean, I have a whole list of things at this effect, and I would love to go through it. But like, just let's start with your existing code base. Like, what does this mean for your existing applications? Like, what do you think a migration to edge computing even looks like?
Yeah. So again, I think this is like initially is going to look like well, okay. So I mean, let's think about like a traditional like application architecture, right? I came from the Ruby world back in the day. It's been a long time since I've done any Ruby and Rails or anything like that, but that's where I came from. And so, a lot of times we would have what we referred to as middlewares, and
Mm-hmm.
things that would be running like kind of uh, between like the actual like web server itself and like the core business logic, right? And so if you think about it like that and go like, okay, well, those would probably be the easiest things for me to try to moving out to the edge, right? If there's just a thing that is say like completely stateless, that is
Yep.
just processing a request and modifying it, transforming it along the way, like that's a really easy thing to move out there. And I think that like, when we start thinking about like the architecture of like React apps, for instance, like
Mm-hmm.
there's going to be some really easy wins with that, with like server-side rendering and things like that, that doesn't actually need to be inside of the core application, doesn't need direct access to the database, for instance, to be able to
Right.
do it. Um, but over time, I think the limiting factor is, of course, going to be like the lack of, again, direct access to your database, or really like the lack of like a really strong stateful system to work with, right?
Right.
And I think that what's going to end up happening with that is that we're going to have to modify the way that we think about our data, right? Like suddenly man, this is something I've been thinking about for a long time. It is like it's a really tough problem, right? Because we have good solutions for what to do with problems with architectures that cannot have a strongly consistent database, that can't have a strongly consistent distributed system, and instead have to be eventually consistent because of the distribution mechanisms happening with. Um, the problem is that they're not all like, they don't naturally fit the way that we as humans think about problems, right? They're all like these eventually consistent ideas, which you have to imagine like multiple different things happening concurrently, and like how
Right.
these things merge together or don't merge together, and like, you know, things happening in different orders in different places, right? Like they're tough to get our heads around, I think. And so I think one of the things that's going to happen is that we're going to end up having to develop like almost use case specific versions of these things, right? So
Right.
you can imagine like, say, oh, I don't know, like a session store that exists at the edge of the network. Well, even that is actually complicated, right? Like, you think about that as like one of the more simple things that that like a web application can do is just, oh, okay, like I have some data that goes along with the session, easy enough.
Right.
Well, when we're talking about the edge of the network, we're talking about thousands of servers, right? We're
Correct.
talking about a user that may be like actually in motion at the
Like
time,
driving. Yes, I was thinking
right?
the same exact, or on an airplane.
Exactly, right. And so you could be connecting to one data center, you could be connecting to one server in one data center even, and then next request you're somewhere else, right?
Right.
And so that data actually has to move along with you for something like a session store. And there's going to be other use cases where that isn't the case, and we have other constraints that come up. I think that's going to be the trickiest part of this whole thing, though, right? Like, I spent the last 3, 4 years working on our computed edge product, like this
Yeah.
specific version of our computed edge product. And I had like, I commented to someone recently that like, I thought I was doing the hard part. Turns out the hard part is actually going to be the state, right?
Yeah,
Um,
totally.
yeah. But ultimately, again, kind of coming back to what I was saying before, like, how we develop applications is going to have to change, I think, in order to take full advantage of this kind of system. And I think that it's worth it, though, right? If
Right.
again, coming back to the idea of like, what if you had the ability to just say like, I want to deploy this piece of code to the place on the network where it is most efficient to run, where it has everything that it needs and nothing it doesn't, and is as close to the user as it can be.
Right.
That's a pretty powerful concept to me. I think that, in addition to the state opening things up, if we can find ways to decompose our applications into smaller components, that's
Mhm.
going to make a big difference here as well. Like moving an entire application, like, wholesale from like inside of your data center to outside of your data center, that's a big ask, right? But if
Right.
I can say, well, my application is actually composed of these 16 things or these 32 things, well, cool. I can, pick and choose the ones that actually belong here and that like are communicating amongst each other and have minimal communications across the wire. Like that's going to be really cool if we can get to that stage.
Hey everyone, I want to take a minute to thank our sponsor, New Relic. If you're building modern applications, then you've got an incredibly complex architecture, which means monitoring it takes a dozen different tools. And troubleshooting means jumping between data silos and dashboards. We all know the pain, and New Relic wants to change that. New Relic's designed everything you need in 3 products. Telemetry Data Platform holds all your data from any source. Full stack observability gives you one place to analyze, visualize, and troubleshoot your whole stack. And applied intelligence gives you automated detection and incident intelligence. Best of all, they're bucking the industry's love of complicated pricing to keep things simple and predictable. No more host based pricing and no more constant upsells for more functionality. And they're giving you one user and 100 gigabytes per month completely free. Check it out at newrelic.com. Observability made simple. I wanted to ask you about the data because that's one of the things where like I can understand and I can wrap my head around building small reusable components that can be deployed to the edge because I do a lot of that sort of with serverless where again you're building small bits of compute, you're separating those things, you're understanding how each one of those things interacts differently. You have to understand how you communicate between functions if that's something you need to do, and so that's something that makes a lot of sense to me. The state aspect of it, though, is just really, really hard to wrap your head around because even if you're doing something like a DynamoDB global replication or something like that, you
Yeah.
pick which regions you want it to replicate to, but it replicates all your data. And in the example that you gave of the session store, if I log in and I'm in Boston, Massachusetts, and then I drive down to Providence or something like that, and then make my way down to somewhere in Connecticut, I've now passed multiple metro areas that my data has to follow along with me. But under normal circumstances, maybe my closest POP is fine. But you certainly don't want to replicate data from a user in Dublin to a user in New York City if
Absolutely.
that user's never going to be near that POP. So understanding what data needs to get replicated, understanding when you purge data and things like that, even what regions you might want to replicate to, again, compliance, security, all kinds of reasons like that. That is the hard part, I think. I
I
totally agree
think
with you
so.
on that.
Yeah, and there's going to be some use cases where like replicating it all over the world is actually the right answer, right?
Right.
But that's, I
For
think,
certain
not
things, sure.
for certain things, right?
Yeah.
I don't think that's going to be the common case, though, right? And like for instance, yeah, exactly as you were talking about, like having a session store for one user that's replicated all over the world makes no sense, right? It shouldn't actually be replicated anywhere until, of course, that user moves in some way.
Right.
And so there's definitely going to have to, like, if I, immediately start thinking about obviously, like as an engineer, I immediately start thinking, well, how would I actually do that
How
thing?
would you solve that?
Right. Like, and it's almost certainly going to require some like collaboration with the client, where the client remembers where it was and can
Right.
tell
Yeah.
wherever it connects to, like, oh, by the way, I used to be over here. Right. And
Hmm.
so now your local one for wherever you are now can then go, oh, okay, cool. Like, let me go back and like get the state that was associated with this user.
Right.
Um, I think, and like state itself is also going to be in it. Like, what does state actually mean, right? Are we
Right.
talking about like are we talking about a MySQL database, right? Are we talking about MongoDB?
Right.
Like, there is actually like multiple ways to think about this, right? So, for instance, one of my favorite systems that has been developed in the last like 10 years is something referred to as Microsoft Orleans, right? Are you familiar with this by any
I'm
chance?
not. No.
Entirely fair. There's no reason you should be. But it was the system that ran the like matchmaking and users for Halo 2, Halo 2 or Halo 3, one or the other. I can't quite remember now. Um, and one of the ideas that they introduced in there was the concept of durable actors. They
Hmm.
introduced the concept of durable actors, and the whole idea here was that like every user, every individual player had a program that was running for them at all times, right? And so if they're not connected, what happens is essentially like that program gets serialized and stored. And as soon as they reconnect, like, okay, we just break that program like in its paused state, like
Hmm.
out of storage, and like they're right back where they started, right? Um, there's
Interesting.
just so many really cool ideas for this, right? Like, so you
Right.
could effectively, like, if we were to go down some path like that, you can imagine like essentially you have a program for you on some particular website that has been running maybe for years at that point, right? And it just keeps getting reconstituted whenever you come and log back in. Um, there's definitely going to be some interesting ideas that come out over the next few years. We're working on some of them anyway.
Right. There's going to need to be, because again, that's one of those things where I'm just like, how does it work? And I think what that sort of opens up to as well is, I mean, the data piece of it is one thing, but and the security piece and compliance, that's another thing. But what about like operations teams, right? Like we still, even in a serverless world, some people talk about no ops. That's not really a thing. You still need
No.
to understand your infrastructure. You still need to, worry about security and compliance and do all those things that operations people need to do. How are operations people going to start dealing with, thousands of pops around the world, or how does it affect them?
Oh man. Yeah, no, this is tricky. Again, I think this is one of those ones where like we are still in the early days of edge computing, right? Because we don't have, or like not many folks have great answers to these questions yet. Um, there's definitely going to be new patterns that come out. There's going to have to be new
Right.
patterns because the things that we do now aren't going to work when we're talking about something like this. Like, what does it mean to be able to like, attach a debugger to a program that is running
Right.
inside of a server in Mongolia, right?
Right.
Like maybe that's actually possible. We have a prototype of something like that working, right? But like is that actually the right way to do it? And or do we just fall back on printf debugging? And like how
Right.
does observability work inside of
Right.
this? Like,
I was going to ask the same thing, because again, you think about that, it's hard enough to observe distributed applications, when they're running in one region in one data center, spread that out across the world. What does that look like?
right, right. Well, and not only that, right, but like coming back to what I said about like, being able to break applications into components to be able to run them across multiple different layers of the network,
Right.
right? So if your application is broken into 16 different components, well, good luck observing that at the moment, right? Um, so this is going to require a lot of work from us and a lot of work from any other like edge cloud provider that comes onto the scene. But we're going to require. It's going to we've already developed some integrations with folks like Datadog and Honeycomb and so on, being able to like
Hmm.
feed data directly back down to them. But it's also going to be about like okay, so if I have multiple components, if I have multiple hops that are happening here, I want to be able to see what's happening between these different places.
Right.
Where did this request go wrong? Where did it get routed to the wrong place? Where did like the data get corrupted or something like that? And I think that's actually going to come back to distributed tracing, right? Like it's something
Yeah.
that we all know this, we've been, this isn't a new concept, but I think it's going to be so much more important than it was a few years ago, right? It was kind of a novelty for, I think, for a lot of companies, for a lot of
Right.
people who were working on it, and like I don't think it's going to be a novelty anymore.
No, it'll just be table stakes
Yeah,
for
exactly.
any, cloud computing. So, so the other thing, though, again, observability and being able to sort of debug is one thing, but what about just like the overall developer experience or just like global deployments, right? So I know a lot of these edge networks now, you deploy one place and it automatically replicates, and that makes a lot of sense. I mean, with CDNs, it's pretty easy. You just, publish to the origin and then everything picks up from there.
Sure.
So those types of global deployment strategies, how are those going to be similar with compute? And then mix in the data aspect of it and say, how do I know this node of my compute can access this type of data or can't, or so forth? I mean, that seems like that's a pretty hairy problem as well.
Yeah, that's definitely a hairy problem. I mean, I think it's not actually that dissimilar though from trying to do a big deploy on, like trying to do a deploy onto like a big cluster of machines as it exists
Right.
today, right? You may have like 1,000 app servers for some companies out there. And like you already have to deal with the fact that some of them are always going to be out of date. Some of them are going to be broken. Some of them, and even just when you're doing a deploy, there's going to be this wave that goes through the whole thing.
Right.
So I don't actually think it's that dissimilar. I think this is like possibly the one place where we do have the tools to be able to do it
Yeah.
right now.
But what about like canary deployments and rollbacks and things like that? I mean, that's certainly. I mean, I guess you can just roll back by redeploying essentially, but
Sure.
it does seem like there is more tooling and more sort of thought there's still a little bit of thought that needs to be put into this probably.
Yeah, no, that's definitely true. I mean, in some ways, I think we actually have like kind of a fun advantage with this. You want to do canary deploys? Well, we could actually start rolling out your application slowly throughout the
All
entire
right.
network, right? You put it on one, let it run for a minute, put it on two more, and then like kind of let it epidemically spread. Sorry to,
Right.
reference epidemics at the moment, but like, let it spread throughout the network in that way.
Right.
Um, yeah, yeah. The developer experience question, though, that you brought up is such an interesting one because, like, this is something that we talk about internally quite a bit. We had a internal like engineering summit a few months back, and at the end of my personal talk that I was giving in there, I brought up a couple things that I'm worried about, right? That I'm like, we don't necessarily know like how to do this thing yet, and I think it's super important. And one of those is the developer experience for it. Like, it's one thing to be able to say like, great, like 3 steps, you can have something deployed at the edge, right? But like that's not really the same thing as building an entire application from scratch or
Right.
like breaking apart an existing application and spreading it onto the network and spreading it across multiple layers. I don't think anybody has the answers to this yet. I think it's going to require some new technology to do it. And so that's something that my team inside of Fastly is working on at the moment. Is like, especially in the WebAssembly world, like, do we have the tools that we need there to be
Right.
able to, you know, take multiple different components and have them work together seamlessly without it feeling like, every hop is like a new network hop for you
Right.
effectively.
So I do want to talk about WebAssembly, but before we get there, a couple other things, sort of on like sort of big questions, and these are like maybe some of these are theoretical at this point, but
Sure.
things like regional compliance, right? So picking and choosing where or what pops your applications and your data replicates to, like, is that something you see as I mean, a problem that you're solving at Fastly, or something that you will be solving?
Right. I don't want to say yet whether or not that's something that we are actively trying to solve or will solve. But I do think it's like actually a really interesting problem that is likely not going away anytime
Right.
soon, right? Like, we've been dealing with this for a number of years in terms of like, say, China and like, European laws, as well as like, we've seen pushes for this inside of the US as well as inside of like places like Australia, right?
Right.
Um, and, regardless of what you specifically think about like those laws, uh, they're clearly not going away, right? Um, I think that edge computing is actually in kind of an amazing place to be able to help developers solve this problem for their users, though. And one of the reasons for that is because, if we do have locations in all of these different places, like it makes it easy for you to say, like, okay, this user is coming from there. their data can't follow them. Kind of harkening back
Right.
to what we were talking about with that session earlier. Maybe your data follows you all the way through the US as you drive across, but then, you hop on a plane and head over to, Japan, and maybe it doesn't follow you over
Hmm.
there. And okay, well, that's fine. It just means it's going to take you a little bit longer to get it while you're over there, right? You're going to have to hop back over to the West Coast of the US to get it.
Right.
And you know, that's something that like would be really, really hard without edge computing, without
Right.
something
That's
like edge
also true.
computing coming in, right?
Yeah.
Being able to like serve users in all these different countries, it would be nearly impossible. Or at the very least, you're having to do a ton of the work yourself. Yeah. So I think this is something that like edge computing is poised to be able to solve for people. But I don't want to say much more than that at the
Yeah.
moment.
Well, I think it's interesting because what you potentially get there is a little bit of compute, even if it's that small piece of compute that says whether or not a particular file can load or a particular document can load based off of region. It's just much more accurate, or it seems more accurate than trying to guess people's location from their IP address, for example. Especially when people are using proxies and things like that, where some of these other things are harder to fool. So I think that's really interesting. And then I guess one of the other questions I have around this too is we always get this question of vendor lock-in, no matter what you're doing, right? So I'm using AWS. So if I'm on serverless in AWS, I'm using Lambda, I'm locked in to Lambda. And to some extent that's true, but you're also locked into MySQL or Mongo or some of these other things. Like
Sure.
you're going to have to do some work to migrate. But I find it interesting with the idea of edge compute, where if you start spreading around compute, to all these different places in the world, what if certain edge networks have better coverage in certain areas, and you want to use multiple edge networks, intercommunication between them or interoperability? Is this something where you see maybe standards developing around this so that not everybody's doing something different, where, there could be some way for maybe multiple networks to talk to one another?
Oh yeah, I'm so glad that you bring this up because this has been like the basis of our like strategy in this area. Like we recognize the fact that like building out an edge compute network is not something you can just do by yourself, right?
Right.
Like we are one player in this space, and I think we're the best player in this space. But like we're gonna have to be able to work with each other, right? And even going back to what I was saying with like the different layers of the network, right? When we're talking about like what if I can move a piece of computation to where it runs best, right?
Hmm.
Whether that's on the client or on the server or like somewhere in between, right? That is almost certainly going to require like some sort of standard way of being able to have a piece of computation, a program, and being able to run it in multiple different locations, and expect the same results, right? So this is why we've spent so much time on on the standards around WebAssembly, right?
Yeah.
And I'm undoubtedly going to keep coming back to WebAssembly until we talk about it. But so there's WebAssembly itself. There is WASI, which is the WebAssembly system interface, which is where we are putting a lot of the effort on this like standardization thing. And there are already multiple different companies that are using that at the moment. Like my personal favorite one of these is actually Shopify.
Hmm.
Shopify has an early product that they have put out where you can run scripts of some kind within like essentially working on your shop itself.
Yeah.
And that thing is actually using WebAssembly. It's using some of the software that we wrote, and it's also using that WebAssembly system interface. And so, in theory, anyway, like I can't say 100% if this is the case at the moment, but it will be soon. If it's not, you could have a piece of software that runs on the Shopify platform that'll also run on the Fastly platform that will also run in your browser that will
Right.
also be able to run in the server as well, right? And so to me, I think that like standards are going to be super important for this, and that's why we're putting so much effort into that.
So let's talk about WebAssembly
All
then, and
right.
we can go to some of the other topics later. So
Great.
WebAssembly, again, maybe if people aren't fully aware of what that is, why don't you just give them a quick overview of what exactly WebAssembly is?
Yeah, sure. So WebAssembly is something that was developed for browsers, actually. And so it was kind of a response to, if you think back to like some of your listeners might be familiar with Native Client that existed in Google Chrome back in the day.
Hmm.
And so the
Yeah.
whole idea with this is that it was for running like existing like C and like machine code applications inside your browser. It was used for games and various other things. Some other folks came out with Asm.js, right? ASM.js was a way of taking almost a response to that, being able to say, well, okay, that's like cool and fast, but like, what if we could make JavaScript really fast? What if we could make it so you could compile that C application down to a JavaScript program with just like, a few little tweaks in it, and it would be like nearly native speed. And then WebAssembly was essentially a response to that.
Right.
And being able to say, okay, well, that was neat, and so was native client, but what if we made a standard way of doing this? What if we made a specific like machine code like language that we can compile and we can run as fast as like near native speed, and can run in every browser, right? And so that's what WebAssembly was designed for initially. However, it turns out it's actually great for things outside of the browser as well. At its core, what it really is a like super fast, super lightweight, super secure way of I don't know, cross-platform language, right? And so if you have multiple different languages that can like target this one, then suddenly you have and you have a compiler that works for it. Suddenly you have a platform that works across multiple languages and multiple different like servers.
Right. And I think back to so you said you've been working on web in the 90s, so you're just as old as I am. Remember Java applets, right? Running
Oh yeah,
in which so WebAssembly is like that, but not terrible. Like it's very
that's the goal.
cool. It actually works this time. I just remember how bad Java applets were and everybody wanting to do them. But yeah, so WebAssembly is one of those things now where again compiling down to native, right, runs extremely fast. And I've always I've heard a lot of people talk about browsers being those dumb clients like you mentioned earlier, but you have all this compute power running on your laptop. Why not use some of it, right?
Yeah.
And when you have to use something like JavaScript in order to do it, you just run into all kinds of limitations. But with WebAssembly, it basically opens up that operating system in a way that you can use the full power of it to do a lot of work there. But then that same program or some variation of it, runs at the edge. It runs in a data center. It can run anywhere, and so that's just fascinating to me.
Exactly.
So going back to this, you recently acquired, or Fastly recently acquired the Mozilla team that created WebAssembly, right?
Well, I wouldn't say acquired. We hired them.
We hired them.
But
Okay.
yeah,
You
yeah.
hired them. Sorry.
But yeah, one of the people on that team is Luke Wagner, who was one of the co-creators of WebAssembly. Yeah. And so this was the team that was primarily working on their WebAssembly out of the browser projects, and so they were responsible for crane lift and WASM time, which if you've been working with WebAssembly, those are like nearly ubiquitous at this point. You've probably heard of them. You've probably used them. And when we started chatting with them, we were working with this team to create the Bytecode Alliance a couple of years back, and we've been collaborating with them for a long time. And so when we started talking, we realized that like we're actually working toward exactly the same goal.
Right.
And so when the Mozilla layoffs happened, and they were happy to hop over and continue actually doing the same work that they were doing before, but now targeted at the edge instead of at like a more of a central location. Yeah.
Awesome.
Yeah, they're a fantastic team. I think we were super lucky to get them.
So now that you've brought that team in, I'm assuming that WebAssembly is going to be a big part of Fastly moving forward.
I think that would be a pretty good bet. Yeah. And that's kind of a fun story in itself. Like it's just, this started out as just, a couple people working on it, like over a holiday break a few years back, right? And you hire one person, two people, and now we have like probably one of the largest WebAssembly teams that exist out there, as well as one of the most experienced, probably the most experienced WebAssembly team out there at this point. And so yeah, it is simultaneously very exciting to me to be able to like really get things done. Like Fastly historically wasn't a language company. We're not like historically we're not like a company that produces compilers and so on, right? And so now we have like turned into a world-class place to be able to work on those sorts of problems. But at the same time, like I think that there's a lot of responsibility that comes along with that. Like we've hired up like quite a few people who work in the WebAssembly world and who are responsible for the future of WebAssembly. And like, I have no desire for it to turn into Fastly WebAssembly, right? Like WebAssembly needs to exist on its own. It needs to like, even for our own benefit, like, WebAssembly has to be a strong community, has to be like, a really solid piece of technology that can't just be for Fastly. That wouldn't make sense for anybody.
Right. Well, I think that's super interesting and good for Fastly for picking up that project, because again, I see that as being another exciting step, for serverless computing as well. Just the
Yeah.
ability again to get that speed, that we're looking for. So,
Sorry, can I hop in there for a second?
yeah,
So to me, like you mentioned that, like for the speed in particular, and like I totally agree with that. I think to me, the thing that's actually even more exciting than that is like the ability, kind of coming back to what we were talking about before, is like the ability to be able to take a program and run it just like wholesale, like just
right.
bop, bop, whether it's on your serverless platform that is running in a central cloud, whether or not it's in a regional area, or whether or not it's like in a cell tower somewhere or
Right.
in the browser, right? Like that is such an exciting thing to me.
Yeah,
Anyway,
no, I
please
no,
continue.
totally agree. All right, so let's jump back to edge computing for a minute here, and one of the things that I think is sort of interesting with the amount of compute you can currently do at the edge. It is very, very small. Like I think 50 milliseconds, or I mean, depending on which cloud it's on, or which edge provider. So, what are some of those limitations that you're going to see? I guess edge computing versus your traditional, which is kind of crazy now. But I mean, you think about distributed computing, we're talking about hundreds of data centers probably, anyways. But edge computing versus sort of the data center approach or the cloud approach. What are some of those limitations that you're going to see? And do you think that it kind of lends itself to this hybrid approach where some of the compute is done on the edge, but then maybe the more heavy stuff is done, in a cloud computing data center somewhere?
Yeah. I mean, the limitations for a lot of the edge computing providers, including us right now, are very low, right? Like that's just a thing. 50 milliseconds isn't a tremendous amount of time, but it turns out that for a lot of the things that like a lot of these initial use cases, it's actually enough, right?
Right.
When we're talking about doing like a GraphQL request, like the actual like computation time involved with that should be relatively low. That's something that I think we'll see like lighten up over time. You'll see this those numbers start to go up as people gain like operational experience with it, and as the demand as well for like more computation time like increases. But I think that you actually hit the nail on the head with this actually being about a hybrid approach, right? And the reason for this is that like does it actually make sense to do 30 seconds of like hardcore like number crunching at the
Right.
edge, like in someone's neighborhood, where you have had to like, buy up a little piece of real estate in order to put your server? Or does it make sense in some cases for that to actually fall back to a centralized data center where like, you have those massive computers where you have like, thousands of servers all running simultaneously? I think that's going to be a theme for the next couple of years is like, I mentioned it earlier, is like, where is the most efficient place for me to run this, right? Do you actually really want to do 30 seconds of like hardcore computation at the edge, right? Or I think I think that like we are eventually going to see a lot of computations, a lot of the shorter computations moving out to the edge, and a lot of those like heavier weight computations moving back into like a centralized data center, right? Like that seems like the natural progression to me.
Right. And I think that some of those use cases too are small bits of compute at the edge that maybe trigger larger compute jobs
Yes.
asynchronously that then sort of prepare data so that it's easier to get, or whatever it is. I think that's a potentially interesting way to think about it.
Yeah, I think that's fair. But also, like, I think the other thing that comes to mind to me is that, like, if we are 10 milliseconds away from your end user, right, and you're doing, say, 150 milliseconds of computation, let's say half a second, let's say 500
Mhm.
milliseconds of computation. So now your total round trip, now your total time to do this is 10 milliseconds to get to you, 500 milliseconds to do the computation, and 10 milliseconds back. So we're talking about 520 milliseconds. Your actual data center might only be 200 milliseconds away from that user, right? So is the savings of time worth it in this
Right.
case? And I think this is going to end up being that balance that like comes out.
And that comes down to intelligent sort of networks too, right? Like being able to
Yes.
understand what's the closest one. So speaking about networks, this is a very big market, right? Like a lot of people are getting into this. So Fastly's been around for quite some time, but you have, Cloudflare and Akamai and AT&T, the mobile
Yeah.
companies getting into it. There's a bunch of them. So, I guess maybe my question here is, who's gonna, and maybe you can't answer this, but I like to think of these bigger questions here, like, but who's gonna win? Is it the hyperscalers? Is it going to be is it going to be the telco providers like the Verizons and the AT&T, or is it going to be more neutral providers, you think, like a Fastly? I mean, I know you
Sure.
hope you win, but I mean, like, or is it just going to be a combination of everybody working together?
I am an optimistic type of dude. Like I'm very kumbaya, I guess. I guess you would say. Like I think that it's almost necessarily going to have to be everybody. Like in order for this thing to work, we are going to have to learn to work together on it. Like one of the things I say a lot internally is like we. I don't want to compete over the basics. I don't want to compete over like who is able to run WebAssembly. I don't want to compete over who is able to run an edge computing network at all. I want us all to be able to do that. And then like once we have all reached this like level of like, okay, now users can actually use all of these different things. Let's compete over the features on top of that.
Right.
Like competing over like the ability to like do basic stuff isn't good for users. No one wants that. Um, you know, that's I think a lot of the times how we think about like standardization work as well, right? It's like, we want to bring some of our like, I don't know if I would say competitors, but some of the folks who are also in this space, we want to bring them along with us and be able
Right.
to say, look, like we're not just developing this for us, we're developing this for everybody. And like, cool, like you deploy this too, and then great, let's compete over what we do with it,
Yeah.
right?
Yeah. Well, it's funny
That's
because
my take.
I almost look at I look at edge computing almost as like another utility, right? Like similar to the internet itself, right? I mean, you're not people, even though there are companies that own pieces of the network for the internet. I mean, for the most part, it's pretty open, right? And
Yep.
so I could see cloud computing or edge computing becoming one of those things where everyone's participating in sort of this as you said, kumbaya, sort of everyone's, creating this thing together. But then building features and applications on top of it is sort of where, is sort of where the differentiation might be.
Yeah, I mean, I think there's some pitfalls in thinking about it strictly as a utility, but I like that, but like that direction I think is reasonable, right? And like again, just to reiterate my point, like I really want us to compete over like the content, like the meat of this problem, not over like the basics, not over the
Yeah.
infrastructure itself.
Right. So then another question is, I mean, talking about competition and sort of, we talked about the hybrid piece. So do you see edge compute as being sort of a competitive thing to, public cloud providers, like where people could eventually host all their applications there? I know you mentioned that you see that sort of, I guess, the hybrid approach, but I'm just curious because there is this thing called fog computing,
Hmm.
you know what I mean? Which is, and I don't know if maybe you can explain it, but where you're using a combination of all these different services, edge, and potentially your own data center, public cloud, things like that, and mixing them all together. So, is this something where you think it's just going to be all these things working together, or is there going to be a niche space for purely edge computing services?
Oh yeah, yeah. I think there's definitely going to be a space for like just purely edge compute services. Like a lot of our services inside Fastly work exactly like this. We do everything we can to avoid having a centralized component for almost
Right.
anything. And obviously there are quite a few things that we have to, but actually, yeah, I think that like the most common case is going to be that hybrid one. To me, edge computing, edge only is always the ideal. Like honestly, like if I set aside my own personal interests from this and say like, honestly, client only is really the ideal, right? Because then there's no network involved. You don't have any of the failures associated with that. But of course, that's not realistic for most things. Um, Edge only is the next best thing, but I think that realistically, hybrid is going to be like where most applications land. I would have a hard time trying to define fog computing because I remember reading about fog computing in like 2002 or something like that. The idea has been around for a long time, and I'm not sure what
Right.
exactly it's evolved into at this point. But it sounds like, based on what you said, similar to what we're talking about, right? Where like ultimately, like I think what developers are going to need to do is stop thinking about their application as a thing that runs in a place and start thinking about it as something that is actually spread across the whole network, right?
Right.
And again, I think we have kind of already gotten there to some extent when people think about their client as just being part of the same application. And so it's a much shorter hop now, I think, to like edge computing being part of it than it would have been, a few years back.
Yeah. No, that's a super interesting way to think of it. Because yeah, I mean, that's one of the things is wrapping your head around that your application does not run on a server somewhere anymore. It runs everywhere.
Yeah.
And you need to be hyper aware of what that means for communication, what that means for security, what that means for reliability, for resiliency, for all these other things. Observability, like we talked about, that is not an easy thing for people to wrap their head around right now.
Yeah, yeah. I mean, I think that honestly the React developers out there are going to be in one of the like stronger positions to understand and really use this, right? Because like
Yep.
React has this concept like built in. You have like the server only components, you have like the client only components that go along with it. Well, why not an edge only component? Or why not
Right.
the ability to like move some of those between multiple different locations, right?
Right.
Yeah. I mean, I think back to like the ASP.NET days when I was like doing that, in the early 2000s. I'm like, they had a couple of these concepts in there. They were almost there, right?
Right.
Obviously it
Right.
stuck around and there are plenty of .NET developers now. We'll see.
So, but that's an interesting point, though. Just again, I mean, even early 2000s, even the 2010s, we were still just learning about microservices, right? And now we're doing serverless compute, and we're doing containers and Kubernetes and all these other things that are just becoming. The technology is moving so quickly, and again, serverless at this point is probably 5-6 years old, like a solid maybe 6 years old. If you think back to the beginning of Lambda. But with things moving so fast, I mean, I look at edge computing as like you're still day zero. Like, I mean, so far to go, right?
Sure.
And not to use the AWS term, but basically, you're still right at the beginning. It's a very, very new thing. So what's that path forward? Like, what I always ask my guests, like, what do you think serverless computing is going to be in 5 years? Like, I'd love to ask you, like, where do you see cloud or edge computing being in 5 years?
Yeah. So in some ways, I actually want it to, and this is it's hard to put my finger on exactly what my answer is to this. I simultaneously believe and want it to be, obviously way more prevalent than it is now, right? Like I think that this will be a common piece of folks' infrastructure. That said, I also believe that it won't be obvious that that's the case. That like this will just be another layer in your stack. Like this will just be part of what you naturally do, or you're not even thinking about it, right? Like, in the same way that you're not necessarily thinking about like the individual server that you spun up on AWS, right? Like, just deploying onto Fastly or even some other edge cloud network, like, rising tide raises all ships in this case, I think. I think will just be such a natural part of developing a high scale application that like it won't even be a question, right? Like I won't necessarily have to be on podcasts explaining edge computing because people will know what it is because they're using it.
Right.
Again, I think
ahead.
it's also going to change how we develop applications. Like as we were talking about earlier, right? Like, it's hard to, the entire concept of like a monolith application can't work in a situation like this. It's already like, and we've already seen this broken down again from like the server to client division. It's going to have to be broken down even further, in my opinion. I think we'll see that in the next 5 years.
Yeah, that's crazy. Well, anyways, I think there's a long way to go, but you're clearly doing some amazing work over at Fastly. So thank you for that. And thank you for being a guest and taking the time to talk with me. And I know I learned a lot from talking to you. Hopefully,
I'm so glad.
Hopefully the guests found this enlightening. And I would say study up on edge computing because that's the next thing. We'll have to start an edge computing chats at some point. But anyways, so thanks again for being here. If people want to get a hold of you or learn more about what you're doing at Fastly, how do they do that?
So check out fastly.com. You can find me at tyler@fastly.com. And I don't look at social media anymore. So there you go.
Well, that's not a bad thing these days. So anyways, well, again, Tyler, thank you so much. I really appreciate it.
All right. Thanks for having me, Jeremy. I appreciate it.
And that's this week's Serverless Chat. I want to give a huge thank you to Tyler McMullen for being my guest this week, and to our sponsor, New Relic. If you want to check out the show notes and a full transcript of this episode, you can find them at serverlesschats.com/84. For more Serverless Chats, subscribe, sign up to be an insider, check us out on YouTube, and follow us on Twitter, Facebook, and Instagram. You can connect with me on Twitter at Jeremy_Daily, and if you want to keep up to date on everything serverless, make sure you subscribe to the Off by None newsletter at offbynone.io. Thank you so much for joining me, and I look forward to chatting with all of you again next week.